Good evening, students. I am Mrs. Parvati, Holy Hearts Educational Academy, PGT Physics, Raipur, Chhattisgarh. Right? In last class, we have done stopping distance and also Galileo's law of odd numbers. This class, I would like to discuss about reaction time. What is the reaction time? When a situation demands, then our immediate action, what is our action? How we will react and what we will observe. That time, it takes some time before we act. That time we call it as reaction time. It is defined as, reaction time is defined as, it is a time a person takes to observe, think and act. It is a time taken by the person to observe. I have observed. Then I have to think. Then I have to act. That is called reaction time. Okay. In what way we can explain very easily? I am driving a vehicle. Then in front of me some vehicle is coming. Then first of all I have to observe. Yeah, vehicle is coming in the opposite direction. What I have to do? Just I have to think. Okay. Then I have to act. Accordingly, I have to apply the brakes or whatever it is. I will change the direction of my vehicle, whatever it is. So, the time taken by the observer or by the person to observe, think and act, that time we call it as reaction time. To find the expression, we will narrate or we will describe an example. We will take a table. On the table, take a ruler or any object you place it. Ask your friend to hold the ruler. You know the height of the table from the ground, that is h or x distance, y we can call it as, right? When the body is dropped from there, from the table, what is initial velocity? U is 0. And what is the acceleration? G, because the body is dropped from a height. So you know whenever a body is dropped from a height, the acceleration is equal to G, acceleration due to gravity here. So which equation will consider? Second equation. So here, to explain in detail the reaction time, consider a table. On the table you place a ruler. Ask your friend to hold it. Initial velocity is 0 here. Then you keep your hands at the bottom of the table and catch it. How much time it will take? That you keep the hand like that. Okay. Then it will fall down here. How much time it will take here? S is equal to ut plus half at square. A is plus g and u is 0. So then substitute the values here. S is equal to half into g into tr. Tr is a reaction time and whole square, or tr is equal to under root of 2s by g or 2s by 9.8 here. In this way you will find out the reaction time here. Got it, students? Okay. So the next topic is relative velocity. What is relative velocity? Very good example. You must have travelled in the train many times. When we sit in a train, if it is moving and another train in the parallel track, another train is moving with the same speed, we feel that we are at rest. Our train is also rest, that train also rest here. Right? And if you are sitting in the train, if you observe through the window, the trees, mountains and houses are moving backward direction and we are moving forward. Why it is so? Actually they are moving backward direction? No, they are there only. They are fixed. Isn't it? So that is due to relative velocity. Got it? So relative velocity is defined as the time rate of change of displacement of body with respect to another body is called relative velocity. Change in displacement, relative displacement of the two bodies with respect to time, that is per unit time, is called relative velocity. Okay. So if you solve the equation for relative velocity, it is very easy. Then we can solve the numericals also based on that here. So let us obtain the expression for relative velocity. For that, we will take the coordinate system. 0 is the origin, x-axis and y-axis, you know it. we will consider only one dimension. This chapter belongs to straight line motion, so one dimension moving along x-axis only I am considering from the origin. Right? At 0 time, as soon as I entered in that room, there are two objects A and B. One is at a distance x0 here. The body A and B I have taken here. X0 A, XA0 is the distance covered by the body A at 0 time initial, and similarly XB0 is the distance covered by the body in 0 time here. Then after t seconds, with a velocity VA of A body and VB with A body moving some other distances. What are those distances? Those distances are XB0, XBT at time t and XAT for body A here. So what is the change in displacement here? XBD is equal to, what is the velocity of B? VB is equal to XBT minus XB0 upon t. We know that rate of change of displacement is called velocity of B. Similarly, velocity of A, XAT minus XA0 upon t is called VA here. Right? We got VA and VB here. Now, what is the value of XBT? XB, we got the equations here. XBA, that is this change in displacement of the body with respect to A. Displacement of the body with respect to A is called XBT minus XAT. Let us find out this equation. Substitute the values here. You will get the equation XBAT is equal to XB0 minus XA0 plus VB minus VA into T. This VB minus VA is called relative velocity of B with respect to A. Got it? Relative velocity of B with respect to A is called VBA is called relative velocity here. If you solve one problem, you will understand much better way here. So the relative velocity is defined as the rate of change of time rate of change of, rate means per second, time rate of change of displacements of the two bodies in a given time, that is per unit time, that is called relative velocity. Formula is VBA is called relative velocity of B with respect to A is VB minus VA. Then relative velocity of A with respect to B, that is VAB, is called VA minus VB here. It's clear? So in the next episode, children, we will solve some numericals and all. So take care. See you. Bye bye.